Thanks a lot, guys. Yeah, this is the first time I'm doing a meetup talk, so please expect a lot of goof-ups. And if they don't happen, well, I was lucky. By the way, this is the first time I saw so many people in one room who are so enthusiastic about CSS. I've never seen this happen before. So who I am, I'm Dipro. I work for DAZN. I'm a backend engineer. Some of my colleagues are here as well. Yeah. So what we do is we stream live sports across a few countries across the globe. And what that means is that we handle a lot of critical services in production at very, very high scale. And yet, some people in the company decided to use Node.js as the application language. And I've been writing Node.js in production for a few years now. I wrote an accountancy software before this job in production. And every time I say this to people who are not familiar with Node.js or who are not very fond of it, often they come up and say, oh, wow, how could you write something so critical in Node.js in production? And yeah, I asked myself the same question. I've been on this path of discovery for some time, and I've been trying to read a lot of stuff and actually question myself. Because the reason why I came to write Node.js was not because it's the best framework around or because of those reasons. I wrote Node.js because I like JavaScript. It's a very powerful tool, very powerful language, easy to learn, very easy to onboard yourself with. And you can do a lot of cool stuff very quickly with it. And there are a lot of frameworks and a lot of libraries around that you can use. The community is vibrant. JavaScript is sexy. That's what I think. That's why I started writing Node.js. And it gave me the platform to write backend services, which also excited me because I could do a lot of stuff. I could read files. I could store data in a database. I could work with SQL. I could work with file storage. I could actually write API servers. Some things that I could only do in the past, writing Java, because when I studied computer science engineering, I was only learning Java as a backend language. And I didn't really like Java. I'm really sorry, this is no offense to anyone, but I didn't really like Java. And fast forward, when I started writing Node.js, for me it was like, wow, this is amazing. So that's why I still do it. And then what I learned along the path was that I wanted to write better code that would actually give me a lot of confidence when I ship these services to production. I would actually know what is going on, right? And that's the intent of my talk, that I'm not just here to just give a meetup talk. Of course, that's fancy. But what my real takeaway, what my real intent is to share with you what I've learned, what I feel, also some of my personal preferences, how to handle errors better, how to have better monitoring, how to have better predictability. Like I've always learned in computer science how to write deterministic algorithms, and now all of a sudden I'm introduced into non-deterministic algorithms, where I actually don't know how long it will take. And that's the majority of my work. Most of the work that I do is non-deterministic because it's asynchronous, right? And I've learned multi-threading in other languages, and then I come into JavaScript, and then it's single-threaded, and I don't know how to handle concurrency because JavaScript is apparently a single-threaded language. So how do you handle lots of stuff at the same time? So we are going to discuss that as well. And we are going to look at the various phases of the event loop. Oops, I do need to give my laptop a bit of attention now and then. By the way, I didn't do a PPT slide because I'm a software engineer. I don't know how to do PPTs. So I just did a markdown file on my repository, and I will share this after the talk. So what is Node.js? As you can see, like we had the discussion previously with CSS, whether it's a programming language or not. Node.js is clearly, it's a JavaScript runtime built on Chrome's V8 JavaScript engine. And if you want to learn how V8 as an engine interprets and compiles JavaScript better, there is a fantastic talk on this by Francesca Hinkelmann from Google, who is a V8 engineer. And I have also mentioned her blog in my references. And I've also shared the videos that I would like you to also go through, because she does explain in detail how to do performance profiling with V8, how to use the API, how you can probe your functions better. I think those two are great videos. And of course, there is another video that I shared, how event loop works in JavaScript, not just in Node.js, but in JavaScript in general. I think that's one of the most viewed videos on this topic. And of course, coming back to the to the topic itself, as an asynchronous event-driven JavaScript runtime, Node is built to help us design scalable network applications. To give an insight, what I'm doing right now with some of my colleagues over there, we are building a data ingestion service that is taking lots of files, parsing them, taking lots of data, and then streaming them into a data storage. And we are doing all this in Node.js, right? And at very, very high scale, because our service scale is around million users, million requests per second. So how are we able to do this using Node.js? Coming back to why Node was built to help us do this, at the heart of the design of Node.js is the fact that we, as developers, we prefer to write structured code. We prefer to write code that does what we want it to do. If we introduce the activity of delegating stuff to threads and workers, and we have it in our service, then we are doing two things. We are writing our functions, as well as we are writing the act of managing threads. And I, as a developer, at least I do not want to do that. I want to delegate that activity to something else. And that something else in Node.js is Libuv. Libuv is a library written in C++ that helps Node.js manage its workers under the hood. And it's a black box. And I'm very happy that it's a black box, because I don't have to worry about it, right? And the complexity of multiple simultaneous operations where possible I/O efficiency, blah, 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 that is completely delegated outside. So when I, as a developer trying to write functions, all I need to do is manage callbacks, right? What is a callback? Callback is something that, hey, let's say my friend X, I call X and I say, hey, you know what? I want you to do this for me. When you're done, call me back. After Y amount of time, X is going to come and give me a callback. And I wait. That is what a callback is. And that is at the heart of the event loop in Node.js. So I copied, of course, I shared the link of the official Node.js documentation where you can go through how event loop works. And it's a very nice documentation of all the phases. And I copied the different phases, and I'm going to talk about one of the phases, that is the poll phase. So every time we write an asynchronous function, the JavaScript engine will go through all the functions that we have written. And I can, at this point, I think it's a good idea to show some of my code that I wrote. I will, of course, explain it later what this is doing. I'm sorry?
Zoom.
Zoom? Oh, yeah, of course. So at this point, when the Node.js runtime sees this line, this goes into the queue, and then the actual callback of this function is passed into Libuv, and then Node passes on to the next line, and it keeps parsing the code, right? So it's not waiting until it gets that, until it gets the result of that function. So there is no blocking in the I/O. And this is the heart of design of Node.js, that every time it sees any kind of asynchronous function, it doesn't wait until the function has executed. It passes the executor as a callback to the V8, to Libuv, and Libuv will pass the callback later on when it's done, and then the callback will be synchronously executed by the event loop when the event loop can process it. So what I've done in this code is, in this very simple code base, is that I'm using a API, and thanks to them, I'm going to mention it right away before I get sued for mentioning their API. This is a free API that I'm using for getting a random beer for myself. It's called api.punkapi.com. So as you can see, I'm also carrying this beer on stage. I really like beers. So I wanted to do something with this in my code. So what I did was, I wrote a function that would call this API and get a random beer for myself. And of course, blah, blah, blah. And then I get this. And if for some reason this object doesn't have what I need from it, I hardcode my favorite beer, Iwit, which I think is the best white beer of Amsterdam. And then, yeah, if something goes wrong, of course, I say beers were not found, and I log the reason. So this is what I'm doing. And then I have some benchmark functions. And then I have a file here in my code base, which basically has an integer. And it gets that. So it reads the file, it gets that number, and I store it. And then what I do is that number is a double-digit number, so I try to sum the digits. And then after I have done that, I write this line into another file. So I write that sum as the price of this beer and the name of the beer and the tagline of the beer. Right? And I'm going to run this function now. And I don't expect it to work because I'm not connected to the internet, so this shouldn't work. Yes. So if you see, this is too much. I need to run it again. Yeah. So of course it says that beers were not found because this address is not there. So what I'm going to do is I'm going to turn on my Wi-Fi, which is connected to my hotspot, so I can connect to this anytime. And I hope it connects, because otherwise this is pointless. It doesn't. I'm sorry. It's going to be on in no time. Yep, I'm connected now. And that's it, right? It ran. So what happened here is, of course, I called the API. I got my beer. I got my number. I got the price. And then I wrote to a file. And this is my output file, beers and numbers. And this is what it wrote. So it is giving me a Riptide, which is a twisted, merciless stout for just 7 euros. Long live that. And what I also did was, at the very end, I have a promise.all, because of course I'm doing two asynchronous things. And if you look at the first half of my main function, I have one line that is awaiting get random beer and another line that is awaiting get numbers, which to me is a bit weird. So I do a promise.all so that I can do it at the same time. And I will come to the reasons why I did that later. I'll also go through what I did with the echo time elapsed, which is a function that is trying to give me a benchmark. So what I do is in this function, I pass the timestamp of the start time when the main function started executing. And I also pass in the name of the function that I'm trying to benchmark, and I'm logging the function name and I'm trying to make the difference, and I'm trying to show you how much time it took to execute that function. So if we go back to our terminal, so when we started, of course, time elapsed 1 millisecond. Then the get beers function executed. Time elapsed was 675 milliseconds. Get numbers, which was reading from a file, took 3 more milliseconds. Get sum, which is a synchronous function, took 1 more millisecond. And then write sum, which is taking all this information and writing to a file, it takes 679. So it's at the same millisecond that I'm getting the sum and writing to the file. So how is it possible that we take 675 milliseconds to talk to an API, and then just 3 milliseconds to read from a file, and 0 milliseconds to write to a file? Of course, that's not the case, right? So what Node has done is, it has passed a handler for every awaited function that you see. So every asynchronous function that is being awaited is giving a handler back to the variable. And that handler has a pointer to a promise, right? And what is a promise? If I go back to my talk material, a promise is basically, in real life, if I tell my friend that, hey, I promise you, I will review your PR in time. And then I don't do it, right? Because, well, I don't keep my promises in real life, and I said that in my bio as well. But if I do keep that promise, if I do review that PR in time, and I go back and say, okay, hey, you know what? Right now I'm busy. I will come back to you later. And then I go and review the PR. I leave a comment. I approve it, and my friend gets that feedback later on at some point. For some reason, if I don't approve it, I leave a comment and I reject that PR. He gets a reason why I've rejected it. It's the same thing what happens in a promise, because at one point, a promise is pending, and then at one point it is settled, And if a promise is settled, it could be for two reasons. It's either fulfilled with a value that is being passed by the resolve function, or it is rejected with a reason that is being passed by the reject function. And this is an improvement on the earlier node callbacks that we used to do, which because it resulted in callback hell, and it was a pyramidal code that nobody wants to read, nobody wants to maintain. And as some of us have already seen it, if you get a legacy Node.js code with callbacks, it's just very, very hard to maintain it. And I will show an example of that because sometimes we do need callbacks. It's just very difficult to avoid it. So in my function where I'm trying to call the API for beers, I use the native HTTPS module. And in this case, I have to use a callback because there is no other option, right? So I have a callback with the response, and I'm listening on the data event of res. And then I'm trying to read from the buffer, and I'm trying to push into an array all the lines I'm reading from that. And then when it ends, I resolve with that response. And if it errors, which it did earlier when I had no internet connection, it rejected with that error. And that error was the API was not found. If I had followed the same criteria, if I had followed the same style in all this code here, this would not be straight line code. This would be very hard to read. And the moment you keep scaling your code and the moment you keep having new developers who probably are new to Node or who are not new to Node, it would be so hard for us to read. But the moment we have this awaited, you can actually wrap it in a try-catch block, which is great because you can handle your errors. It's easily readable. And it's just, yeah, you can log. You can pass your logs at every point. You can pass a log after awaiting the function, which means that you have a success log. And you can have an error log in your catch, which means that you can actually have super high monitoring. Because when you have an incident in production, it's very important for us to go and check where exactly that error came from. And this gives us that. Whether you work with Azure or you work with AWS, we have all the tools that we need to give us all the insights in production. All we need to do is have a try and catch. And people who have come into Node.js from other languages, they are familiar with the try and catch syntax. And because of this new introductions to JavaScript, it's just super easy to do that. But of course, going back to the earlier code that I showed was the promise constructor. Coming back to the analogy that I shared here, is that at some point the promise will resolve the value. But what happens if I just do promise.resolve 5? Does it return a promise, or does it return the 5? Or is it synchronous, or is it asynchronous? If I ever do promise.resolve 5, it will resolve synchronously with that value, 5. Why do I do promise.all in my main function? So let's say that we have, 5 or 6 different sources of data into our function. And in our function, we also have 5 or 6 different destinations of our source, right? And my function is trying to transform the data and just pass it on. And it has several such lines. It could be a for loop. It could be a map method where you're just doing something asynchronous on every data in an array. What do? What we do is we just get the promise from that asynchronous function, and we pass it into an array, and we do a promise.all on that. And the caveat to promise.all is every promise that you're passing in that array has to be error handled. Because if you don't, then the promise.all will reject with the first rejection. So it will not continue executing the rest of the promises because it has already rejected with something. In this example, both my getRandomBeer and getNumbers is handled with errors. So if I now go to my file.io function and show what I'm doing with the getNumbers, what I do is I create a read stream from my file path, and I'm listening on the readable stream. By the way, a stream is in computer science is a sequence of ordered binary data. So if you're handling large volumes of data, it makes sense to use streams because it doesn't make sense to store all of that in memory because that's just not good computing. So what we do is we listen on the data event, which is basically trying to handle chunks of that stream and doing something with it. And of course, if you're using streams, you need a buffer because you have to store it temporarily in a small piece of memory. And that's what it's doing. It's trying to convert that from that buffer to a string. And then it's trying to convert that number into digits. And then when it's done, when the end event is emitted on that stream, we resolve it with the integers array, and that's it. And if there is an error, we of course reject it. It's the same style that I had in the API call as well. And of course, in the write stream function, there's not much to do. It's just I write it, and that's about it. And because both my promises are handled, so it could be that in either of these functions, I have an unhandled rejection. Then in my main function, the promise.all will reject, and I would probably miss out on something. And what that means in production is we have no idea what the state of our application is. So it could be that our application errored out at line 47, or I don't know, line 49 at any point, and I don't know what was the last written data, what was the last executed part of my code. And that's where my nervousness comes in when I'm writing code for production, because I need to know what I have done successfully. I need to know what I have failed at. This is basically getting feedback. It's just something that we also need in our personal life. This is what it allows us to give. Going back to the benchmarks, if we try to see how much time it took for us to do sequential execution of the asynchronous statements, it took us 679 milliseconds. And how much time it took for us to do it in promise.all, it took us a bit less than 600 milliseconds, right? So it shows that promise.all gives us better optimization in terms of time complexity. Okay, I'll go back to my talk content because I think I have covered promises. Going back to the event loop, if you see the poll phase, what it does, I did cover it in the past, but what the poll phase does is every time it gets an input-output event, it will try to delegate it to Libuv, and then once my callback has been executed, I get it back. And then this will maintain the order of execution in my queue. So the poll phase will not be starved, of course, because there is a maximum limit on the poll phase, which means that if it crosses a certain amount of time, the poll phase will be stopped and it will move on to the next phase. And if there are timers, which I haven't covered in this code, if let's say we have a set timeout or a set immediate, that would mean that set immediate would mean that the poll phase will move on to the check phase that will execute the callback passed by set immediate. And if there's a set timeout, that would mean that once the poll phase has successfully executed its functions, it would go to the timer phase, and then the callbacks from the timer phase will be executed. I'm not covering the other phases because I don't know them myself very well, and I haven't needed to. Production insights, yeah. So as I covered already, like what I prefer to do is I want to handle my errors well, because it just gives us better confidence, better feedback. We know exactly what we're doing. If there is 5xx, we know where to look at, and it just helps us. It just helps us at 4 a.m. when we get an incident. Predictability, of course. Some of our algorithms that we wrote will always be non-deterministic, but it will still give us some predictability. We can write benchmark tests. We can write some stress tests, and that will give us what I haven't covered is there is this function called getActiveHandles, and there is another function called getActiveRequests from the process. So Node has a library called process that is native, and if you call the process object and you call its getActiveHandles method, you know exactly how many handles in the event loop you have at that point. And getActiveRequests will also include the timers that you have set. And if you want to profile your function's memory state, then you can use the V8 object, and you can get the heap space and get the memory state at that time. Scalability and readability, that goes hand in hand, because if you're trying to add more features, you're trying to add more load, Of course, promise.all helps a lot, and at the same time, try and catch helps us to have better error handling. It's straight line code, so it's very easy to read. You add new developers, it's very easy to maintain. You can delegate scope of actions to different files and functions. Monitoring, of course, I added a lot of console logs, which is not something we do in production, but yeah, I don't have my logger library here. I have used Winston in the past, and in our company, we have our internal logger module that is connected with AWS CloudWatch. And of course, you can add several such tools in your code for that. References. This is key. So, of course, I was not at this place 2 years or 3 years ago. I didn't know what I was doing, and I needed to read a lot of material. Node.js documentation or MDN documentation is not enough. What I had to read was something that I was also shown by one of my colleagues, the Mastering Node.js book that I can read on orally. Franziska Hinkelmann, her Medium blog is there. She's one of the key figures in Node.js. I think reading her blogs and watching her videos is one of the best things we can do. And of course, the Clean Code Handbook, that is something that I always recommend to any of my peers, because I feel all of us should read this book. It's super important for us. The cool videos I already shared. I have already acknowledged API, Punk API. Of course, thanks to Amsterdam.js for giving me a chance to share my insights with you guys. Thanks for this amazing event. I did come to Amsterdam.js conference last year, and my inspiration for this talk comes from there, because I attended last conference, which was, the keynote was from Douglas Crockford, and he gave a talk on parallelism, and which is one of the aspects of concurrency, and that is why I wanted to give a talk on how I do it in my. And there was also another talk from Andre Stahls on streams, and he's an expert in RX, but he had his own library that would actually show duplex streams talking to each other. That was very cool. So I wanted to be a part of this community, and for me it was a great way, because my company also gave me a chance to come here and share our insights. And of course, Maurizio and everyone at DAZN who did help me in this, in preparing this talk and making it better, all my colleagues who did a dry run with me. And the next challenge, because of course you guys have been very patient listeners, I wanted to also share this link with you. So a lot of people who have been discussing what promise.then or .catch can do, or what async await can do, there is a very important announcement from V8 back then, how performance improvements were done by using async await. And I think this is something that I also, I'm sorry, zooming? So of course, when we are writing code, memory consumption and time complexity are like super important features for us to consider. And I feel that if we go through this blog and we write some benchmarks for every function that we write, it will give us a very key comparison metric to decide whether we should write using promises or to write using async await. I think this blog is really good for us. With that, I come to the end of my talk.